So we're talking about document storage, right?
So we're talking about getting things from a traditional computer to a headset.
Yeah.
So the criteria is it should be no work for the end user after a basic setup.
Yeah.
It's okay if it only works locally. And all the system needs to do is to send up three types of things. Metadata for all the documents on request, not necessarily at the same time, and also metadata about the layout of the document library.
Okay, so locally, right? So we're not right now talking about sharing it with other people outside your local context.
We would like to do that at some point, so it has to architecturally be possible.
Yeah. So the basic idea we were talking about was minimizing the interfaces so any API or any interface is essentially a set of promises. And you want to make the fewest number of promises for as long as you can. Every promise needs to be something that you can't live without. So what we talked about was you have a client, which we can just represent with a circle. And in this case, the client is probably the VR headset, right? And then you have some sort of system that stores and serves the documents. So the first thing to think about is that the interface that the client accesses is as narrow as possible, because interfaces represent promises, and you don't want to make promises you might not want to keep in the future. So a good place to start would be to have only essentially three operations. So create, read, and possibly delete. Because sometimes you make mistakes, so maybe you want to remove something.
Yeah, good point.
But ideally, you wouldn't. I mean, if you have a document that you have published, you probably shouldn't be in a situation where you have to unpublish it. For instance, if you run out of space or something. So
it might be, if you apply further metadata on the computer side, you may want to be able to delete what's up in the headset side.
Yeah.
New version.
Yeah. Yeah, well, we'll get to versioning because that's so one of the ways I develop systems is that you iterate. So you start with the smallest possible thing that solves your problem, and then you add the things you must have later. And for instance, you talked about versioning. We know that versioning is something that you're going to need, but initially we just ignore it. Yeah. The other principle is that the way you actually store the document, you should hide that from. So let's say you store the document in a database locally. So this line is behind the interface. This is the only thing that the client can see. It can only see that interface. It doesn't know anything about what goes on behind. So the first principle is for services is that you hide your storage. It's only the service that is allowed to mess with the storage. And that gives you the freedom to choose a database, flat files, maybe iCloud. If you put files in the document directory and store them on iCloud. So when you create a document, typically what you want to do in order to have a consistent way to deal with identifiers is that you probably want the system to assign identifiers. Because then it can make sure that they're unique, so that you don't find yourself in the situation where you're trying to upload the document and it says, well, the identifier already exists, and then you have to figure out a new identifier, etc. So when you create a document, you just upload it. The system assigns an ID, stores the document, and then returns the ID.
Well, so in a way, the graph is backwards because the circle initially should be the computer, not the headset.
Yeah. So in this sketch, you have more than one client. So for instance, one client might be the utility you use for uploading documents. And that utility might be, able to do a bunch of other stuff, one of them being populating your document store. So we can represent this as we can call it U for uploader, and then we can call this client C for consumer. Yeah. And then the other operations you have, essentially, you need two things. You need to be able to list documents, and you need to be able to read documents or download them. Yeah, and that's basically it. And then we can start to care about things like, so how do you do versions? So you could do it trivially by saying that if you have a new version of a document, you have for instance a replace operation, or if this interface is implemented in HTTP, the protocol has a few verbs. So it has get, post, put, and patch. So probably put is the verb you would use to upload a new version.
So, oops, just going to make it a bit easier to see what you're doing.
Yeah. So one of the things you could do is that whenever you put a new version, let's say when you initially upload a document, you get a document ID, let's say ABC123, and then we can assume that you use what's it called again? Alpha.
At.
Yeah, you use an @ and then you have a version, for instance, v1, or yeah, versions is version numbers is a whole can of worms.
We don't need version numbers in that sense here. All we need is it is an interesting question, because imagine you do this operation once and then you do your headset stuff and you go back to your computer. If you then change one of the documents, such as adding further metadata, you simply want to replace the one that's on the headset.
Yeah. Yeah, we'll get to that.
But it's still, but I'm saying it's not logically automatic, because the headset has to know that this has changed.
Yes, but yeah, that's further down the evolution.
Okay.
So typically, let's say if you want to introduce versioning, then you have the ID, @, and then some sort of version specified. And we can assume that you have linear versions, so 1, 2, 3, 4, 5 initially. So whenever you update a document, you just use this part of the ID when you upload it, and the server assigns a new version for you. So now every document is the ID and the @ and the version. And then you can have a virtual version, which is, for instance, latest.
So where, I have to ask the very basic questions. Where shall this software reside? In the computer application, server, or in the headset?
Which application?
Reader, for instance. Reader for Mac. I'm making an assumption that we have software for Reader for Mac that serves up stuff to a headset.
Yeah. So that would work as long as you're operating locally. If you want to share the documents with others, you probably need to put it on a server somewhere that is publicly accessible. So then you would need a dedicated server that runs a service that offers the storage API for you.
So let's say we use Dropbox, which some of my team are not happy with because it's commercial.
Mm-hmm.
If we do it with the right API interface constraints, they should be able to implement any other storage they want, right?
Yes. But yeah, I mean, you could use Dropbox. The thing is, you would need the service between the client and Dropbox, because you don't want to give anyone direct access to your storage mechanism.
Yeah, so that's what I'm saying. So what we essentially need to develop is a piece of code that anybody, at least on the Mac, can use in their library application. We will use it in Reader.
Yeah.
That will then synchronize our local library with Dropbox.
Yeah.
And
Well, also another thing that you could do is that you could actually stack these. So what you could do is you could have, this service somewhere on the internet as a service.
Can you move the paper more towards me, please? Okay, that's better. Now it's in frame.
Yeah.
Thank you.
So you could stack them. So let's say you have a service that you host on a machine that is available on the internet, where Reader is a client. But on the other hand, Reader has the same service embedded inside itself. So what you could do is, let's say just draw it like this. So what it could do is, it could, if you have your VR headset here, it talks to the service inside of Reader. Reader could act as a cache, as an intermediary. So whenever the headset asks for something that you don't have locally, let's say you just installed a new machine, you fire up Reader, you have nothing. The only thing you know is you have your storage server on the internet, so Reader knows about that. So let's say the VR headset asks for document ABC123. You realize you don't have that locally stored. So you fetch it from the server and store it locally. If you have versioning, it also means that you can make sure that the documents are immutable, meaning that if you have ABC123 at v1, that file is never going to change. That's always guaranteed to be the same here and here. So if you replicate it, you know that that's not going to change. That makes replication easier. So then you can have, as your VR headset asks for documents, you can download them and cache them locally. So next time you fire up your VR headset and Reader, it will just fetch them locally.
So here's the thing. One of our important users and user models really wants collaboration, shared spaces.
Mm.
So second year we'll probably have to work on that. We probably won't do audio, we'll probably still use Zoom for that. Put your headset on, you can share documents. That is important, but in the beginning, I just need this to be super simple. I don't want to spend hardly any programming time on it.
Yeah.
Computer to headsets, do stuff. If there's something there, it's sent back as well. That's it.
Well, let's say we drop all of the access control initially, for instance.
And even version control, that it has to upload everything fresh every single time.
Well, the problem with not having, so if your documents are not immutable, and the documents will update, then the problem you have is that you can't be sure that this is the correct version.
No, but what I'm saying is maybe we do it as simple as every time you launch the WebXR, it gets everything from the local machine. So there's nothing.
Yeah, it can do that. Yeah, what I'm thinking about is if you have a server on the internet where that's your authoritative source of all your documents, and you want to be able to replicate them locally so that, for instance, you can use them offline, then you need to actually care about immutability, so that if you have an object, you know that there's only one version of this object that has this identifying.
I'm thinking more that once you start having multi-player, so to speak, the complexity goes up pretty much exponentially. So it is very important for me to spend a lot of time this year polishing the user interaction. So therefore, having a simple thing on the computer, of course they're all computers, but you know what I mean. The computer says, here's the entire library, can I send you all the metadata first? So it puts that in JSON or equivalent, shoots it up to the headset builds a library, and then when it needs a specific document to read, that is fetched separately.
Yeah. So what you could typically do is, if you have a list operation in your API, typically you would want to have some way of specifying search terms so that you can limit it. For instance, I want documents that have these tags, were produced between these dates. And then the list operation not only returns all of the document IDs and possibly versions, but it also returns all of the metadata, so that you don't actually need to download the documents, but you get a list and the metadata for all the documents.
Okay. You said something very important there. The list itself is the metadata, because each item in there contains all of it, okay?
Yeah, so what you could do is, so let's say you have a document with the ID ABC123, and then you have three versions of it, V1, V2, V3. So then you would have the metadata for V1, V2, and V3.
We don't need to worry about that, because these PDFs will not change. The metadata about them will change.
Yeah, exactly.
No, but you don't want to have to go back. Because the only time the metadata will change is if A, you highlight different text, 2, you do AI operations, and 3, it has a specific layout in XR. And that'll be written back in VisualNet as well.
Yeah, but the metadata will need to be kept in sync as well as the document. I mean, the metadata is, you could argue, part of the document.
It doesn't need to be kept in sync. Obviously, you know this better than me, but I'm trying to be simple for what we need now. Considering that, okay, so the use case, okay, we're at 18 minutes. Can you do a clap or something? That's not going to show up on my scope. Anyway, so this has been extremely useful. So the thinking now is, you're working on your laptop, you need more space. You close your, no, you don't close your laptop, you have to, and you fire up your headsets, go to the URL or whatever the software is on. At that point, the list operation happens and nothing else. And that list operation probably won't take that many seconds to transfer. And then you have your entire library. That list operation is the document metadata plus the metadata about your library, such as what documents are hidden, which ones are pinned, that kind of stuff. And each document metadata includes highlighted text, because that's really crucial. So you then have it, at that point, you may even have a little note on the screen saying synced, and then you can close your laptop if you want to. You do all your stuff, and if you just then disconnect, nothing happens back to the laptop. That's a shame, that's a limitation. But if you do an operation, if you say, okay, right now, let's think about it like an old-fashioned save box, something simple, right? Because I could imagine you have done, and this is the thing in the meeting yesterday, they didn't really quite understand. The metadata that is AI extracted from inside documents is really, really crucial. The metadata of title, publishing year is so basic, right? So imagine you've done an amazing layout, you used all these walls, you've done all kinds of stuff. That bit of knowledge needs to be transferred back.
Mm-hmm.
The way that I have seen it so far, and this is incredibly useful, is that if you open a document, you put a graph over there, then this document's metadata in Visual Meta should say the document graph has been put on wall X. But that is not enough, because you may do that for one document, but we're really talking about the library now.
Yeah.
So maybe what is more important is that the library file, let's pretend that is a dummy PDF for the sake of simplicity, then notes down that document so-and-so has had internal stuff so-and-so, put so-and-so. That's one thing.
Okay, yeah. So what I'm seeing is that versioning the PDFs is, as you said, probably not the big deal here. It's actually versioning the metadata that's more important, because not only are you going to continually change the metadata as you make changes in the VR representation, for instance, but it's also conceivable that you are going to have multiple sets of metadata for the same document based on maybe you are viewing the same document in multiple contexts. So if we're going to use some sort of metaphor here, let's say you have 5 different rooms in your VR workspace. So you have 5 different rooms that represent 5 different contexts that you work in, and the document might occur in more than one context, but it might be organized differently. It might have different metadata. So that means we probably have to explore the way we think about metadata as not just one thing, but maybe it has more structure. So for instance, it's related to some sort of context identifier.
Yes, thank you. I have abstracted this in the wrong way before. I have abstracted working in augmented reality, where you assign this wall for graph wall, that for picture wall. And that is useful. It's also a childish oversimplification. I do think we need to have named environments, right? In these environments, one of them can be VR, which means no constraint about the real world.
Yeah.
But it can, no, actually that's entirely not true.
Well,
you can have different VR environments, of course.
Yeah, and what you're, now the data model is growing. So now we need to model the contexts as well. So, it's always hard to name things. So context is somewhat abstract and not too specific. So, if that maps to rooms or applications or...
Yeah, the thing, that's a good point. The thing is, we have often discussed the notion of you open up a document and you hold it in front of you in this space. Mm-hmm. Where is it? Mm. Is it in relation to the room, the table, your head, your hands? These things are really important. So the idea of having defined walls, I think we should probably do something as in wall front, wall right, wall left. If someone wants to assign them something more interesting, they can do that in a higher level. But for the system, because one thing I've really learned from experimenting in VR is that things that float in space are annoying, unless you can get rid of them quickly. Like we did Ted Nelson lines. Oh, it's like a washing line. You want to avoid it with your head. It's really bad, right? So chances are that flat surfaces are still going to be appreciated. So when you take things up, you won't just have it floating. Of course, for some instances you will, but generally you will put it flush against a wall.
Maybe. I don't know enough about VR environment design.
There will be enough edge cases that it doesn't really matter if I'm right or...
No, but we can try to so when you try to abstract things, you know, you have to make sure that it works for the concrete cases that you know about. That you don't go overboard fantasizing about things that might be useful in the future. You know, try to limit yourself. But yeah, I think that we're going to need some way of describing the contexts, and we don't necessarily know what those descriptions are going to look like. We just need to know that we're probably going to have to describe them. And also, it's very tempting to try to figure out a way to describe them, but you know, that doesn't necessarily have to be standardized. That may be something that the application knows about. So, you know, this is the context description for this document in this room, for instance. The system doesn't need to understand it. It's just a blob of data that application understands.
I think that's very wise, because what is important for me as a developer is that the data things are open. The data connections may be proprietary per room. So in our WebXR, we can allow you to build castles in the sky, but you should be able to go into someone else's software and build an entirely different kind of thing.
Yeah.
And if they can talk together, that would be really nice, but they don't have to. So
yeah,
that's, yeah. So let me be really concrete then. So what you think readers should do is to produce a list of all the metadata of all the documents, which is the visual meta wrapped in JSON.
Yes, and then also when you ask for that list, the service knows that it's that application on that platform that is asking, and then, you know, maybe you also include the contexts for that device and that application.
Asking or sending? You mean headset or computer now?
When the headset asks the storage service for the list of documents. So
okay. All right.
then you probably want to say, okay, these are the documents. This is how they are placed in. This is the context metadata for that application, and when inside that application, that might be interpreted as this document is open on page 5. It's located on that wall. It's about this big. It's placed at those coordinates.
Well, hang on a second. So this is very interesting. So what you're saying is that on the Mac, on the computer software, there should be a server mechanism whereby when it is pinged, asks for stuff, the system asking says, hello, I'm a Meta headset, or I'm just running the Sloan paid for XR environment, whatever it is, some kind of ID. And then the computer software will reply, probably with a generic list, but if there are any special requirements, it will at least know to serve them. So it'll then send this giant JSON with extracted metadata from all the documents. That guy, funny boy. Now, there's two different. Edgar, can you stop that for a minute? You're distracting me. He can't hear me, can he? Right. So it'll send also, probably separately, for ease of think, at least conceptually separately, computer library. These items are pinned, these items are hidden, that basic stuff. That goes up.
On that device for that application, or for that application across multiple of yours.
Yeah, it says on this Macintosh computer environment, these extra things are such and such, right? So then at the end of okay, so logically on handover, that's the thing. Let's call this handover, not transmission or anything, right? Because under this system, you can't really use both at the same time. it would just get a bit messy.
Both.
A computer and headset. You can, but
Why wouldn't you?
because you may make changes on one, and this is not a live synchronization back and forth. I mean, if it can be improved to that, but here's the notion. When you hand off from computer to headset, this stuff goes across. And then you do your things in headset. When you are then done in headsets, when you've moved and done all kinds of crazy stuff, you then hand over from headset to computer.
Actually, I don't think you need to do explicit handover. I mean, if you think about the storage layer as something you put underneath Reader, so Reader goes through the same interface to fetch documents as the VR headset. Then essentially, both can be active at the same time. Of course, you're going to need some sort of mechanism for notifying all of the parties that are interested in the documents that a change has occurred. And there are lots of ways to do that. So essentially, you could think about it as the storage layer. You know, you have one storage layer and you have 1, 2, maybe 10 applications that at the same time can use and modify the context, the metadata.
I think that's good, and that makes sense. But implementation-wise, we can ignore that now, right?
Yeah.
Right. So here's the other specific thing. When you're done in the headsets, you then hand over to in this context, your computer is your main device. You hand back over to the computer. So what you hand over then is kind of ignoring the library list from the computer. You send your own list. Mm. You're saying for the Sloan Future Text software, we have these things. The Reader computer system doesn't even need to parse that because it's XR stuff, doesn't know what it is. Mm. And then that needs to be then sent out in the future. This is stuff that I don't say has to be in a PDF or visual meta at all. This can be in whatever blog. But there is one wrinkle, of course. When you are in the XR environment, if you do an annotation, you're changing the document, that needs to find its way back as well.
Yeah. So and then we're back to versioning. So you need to version the metadata, and you need to notify anyone who is interested in that metadata that there is a new version, so that they can fetch it. And this is why I'm starting to think that maybe you should ignore having. I mean, you can use a local storage server for testing, but I actually am starting to think that you should probably have a storage server online somewhere, because it just makes everything a lot simpler. Because then you ignore that you don't have anything locally, you have everything online, and then having things locally is a later optimization for being able to support offline use or semi-offline use, as is the case here, where the network connectivity is dependent on my phone being in a particular location at a given time.
As it is here, yeah.
Yeah, so I think it would be simpler to have a centralized storage server initially that is just personal for you, and then you could think about making a multi-tenant solution so that multiple users can share the same physical storage server. And then also it might be easier to figure out things that are monetizable, because then if you have things online and you have multiple users putting their data there, and you have systems in place for managing who has access to what.
Yeah. I guess if we do that correctly, then we can maybe use good old Dropbox now, and if someone has a non-commercial solution, they'll just go right in, right? Okay. So you're saying we basically have to have some kind of an online repository solution.
I would say that it's probably easier. And I mean, it's tempting to go crazy and buy lots of services from Amazon. I have a computer that I rent in the data center in Germany, and the way it works is they actually have an auction system. So whenever some of their customers are upgrading their servers, their old servers are put up for auction.
Oh, really?
And the way it works is, so they're listed at a certain price point, and then the price point keeps going down until somebody buys it. And the price you're bidding on is the monthly fee, or the monthly cost. So I think I pay €40 for a server that has 5-6 terabytes of redundant storage.
I pay quite a bit more in America.
64 gigs of memory and a fairly beefy Xeon processor.
So what do I tell my programmers now? I tell my Mac people one thing, and then the lab people we have to do something else. I say that we have to choose an online storage solution, and we have to design it so that...
Well, that's the thing. So I would focus on the square bit, the service. So if you use HTTP, that's and design it as a REST API. So essentially, you have get and post and maybe patch or put operations, possibly delete. And then it doesn't really matter how you store things. So the easy way I always embed an SQLite library in any server I write. And then when I know what the data model is supposed to look like and how I interact with it, I add support for Postgres or other servers.
So I guess that initially the reader folks, Mac people, they can just make reader into a server, right? And then later on, that layer can be changed to be on an online server.
Yeah, actually, the way I would develop it, if I was developing it, I would develop it as a server in the same language as reader is written in. But I would make sure that it's implemented in a way where it can be used as a library. So you can include it in reader, or you can make it a standalone thing.
Right.
So, yeah.
Right, okay.
And then it's, you start with the basic stuff you need, and then you try to, show some restraint. The important bit is really getting your head around the data model. And SQL has been around for a long time, so a lot of people know how to express themselves in SQL, and it's also very easy for communicating relationships between different data types. So here we're going to have, some way of representing the document, some way of representing the metadata, some way of versioning the metadata, possibly also versioning the document. You're going to need some way of representing the different contexts documents can occur in. And those can be, you can have many contexts for the same application on the same device. For instance, if you have multiple rooms, or the contexts can be, on different devices. So you could think of it as the context is the data that actually is owned by the VR headset, for instance. The VR headset uses the storage system to store its, or the application running on the VR headset uses the storage to store its configuration for, a given context on the service. So that you get it from the same place. And then, running it locally is interesting, but it's ultimately more difficult to do because it's harder to demonstrate, for instance. So if you're running it on your laptop here and you need to demonstrate it to some people you're talking to over Zoom, it's a lot of work to give them access to your local computer over the internet.
Yeah, that's a good point, actually.
So that is why, I like old-fashioned servers that I rent that are physical servers in a data center.
So if we use the server that I have, for instance, we just need a SQL database and a few things on there, right? It's nothing sophisticated.
Maybe, yeah. Initially, yes.
And then we have just a few basic users. That should, if we do the interfaces right, then, well, the APIs rather, at some point later on, it should be relatively easy to use a different server mechanism. Is that what you're saying?
Storage mechanism, yeah.
Yeah.
Yeah, so you want to hide the concrete storage mechanism from the user, the application that consumes the API. The API only provides operations for storing, listing.
So does that mean we need a piece of
updating.
software on the server that is above the SQL that just says, hello, this is what you want?
Yeah.
Okay. What kind of people write that? Who should we?
Lots of people. I mean,
That sounds very different from application programming.
I don't know. It shouldn't be. I mean, they should be technically capable of doing it because it's not the most complicated thing in the world to implement.
Right.
But they might not be. So the key is how you structure things and how you think about things. Actually technically doing it isn't very challenging, but you have to be disciplined about, for instance, if you are using, let's say, a Postgres SQL database, you don't want, for instance, you never want to give other people direct access to your database because then they integrate with Postgres, and then you figure out, actually, I don't like Postgres, I want to run this database instead, and then all of their integrations break.
Yeah, gotta be careful, young man. Is your iPad broken, man?
No, it seems okay. But I mean, that's essentially